In this video, I'll do an example of graphing a parabola in standard form. The parabola I'm going to graph is negative x squared plus 8x minus 12 equals y. With this parabola, a equals negative 1, b equals 8, and c equals negative 12. First thing I'm going to do is determine if the parabola opens up or down. Since a is negative, that means the parabola opens down. The next thing I want to look for is the axis of symmetry. To find the axis of symmetry, I want the line with the equation x equals negative b over 2a. And I'm going to substitute the values from this particular parabola into that formula. I'm going to work that out, being careful of my signs. And I get the equation x equals 4. So that's my axis of symmetry, x equals 4, which is an equation of a vertical line. The next thing I want to look for is my vertex. And the vertex always follows along the axis of symmetry. So the x-coordinate of the vertex is also negative b over 2a. So the number I just found, in this case 4. Then I want to go ahead and find the y-coordinate that goes with that. So I take my original equation, and in place of x, I'm going to use my value of 4. And then I'll be able to solve for y. In this case, the y-coordinate was 4, so I can write my ordered pair 4, 4. So now I know my vertex. Next, I'm going to look for my y-intercept. And I always find my y-intercept by setting x equals 0. And when an equation of a parabola is in standard form, the y-coordinate will be c. So for this particular parabola, I'll have the point 0, negative 12. I could always find that by also just substituting 0 in for x. And you'll see that the squared term and the linear term both go to 0, and I'll get y equals negative 12, or y equals the c value from my parabola. I'm going to come back and find the symmetric point to my y-intercept in a little bit when I go to do my graph. It will be easier for me to see it then. The last points I'm going to look for right now are my x-intercepts. And to find my x-intercepts, I always set y equal to 0. I have a choice of trying to factor or use the quadratic formula. Not everything factors, but if it does, that can be a quick way to find my intercepts. I can always use the quadratic formula. If I'm going to factor, I like to have a positive coefficient for my squared term. This has a negative in front, so I think I'll just go ahead and divide each term, both sides of the equation, by negative 1. That's something I can do as long as I do it to both sides of the equation. And once I do that, I'm going to get something that does factor nicely in this case. And then I can use my zero product property to find the x-coordinates for my intercepts. So my two intercepts I can write as 2, 0, and 6, 0. As I had mentioned before, I could have found those intercepts using the quadratic formula. I'll just show you how that would have worked here. If I was using the quadratic formula, I would have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And once I plug my values in, I can go ahead and simplify. excuse me. So I'm going to go ahead and simplify and work that through. And when I do and get that simplified, I'll get -8 plus or minus the square root of 4 over -2. And if I work out those two solutions, I will get the same values I got before. So that's just an alternative to factoring. So the last thing we're going to do is go down and actually do a graph. And for this graph, I'm just going to do a kind of rough graph by hand. I don't have a grid here, but we should be able to get a pretty good feeling. So I'm going to go ahead and look for the points that I have. I know the axis of symmetry is at x equals 4. So I'm going to sketch in that vertical line, just kind of a dashed line here at x equals 4. My vertex was the point 4, 4. So I'm going to add that point. My x-intercept were 2, 0, and 6, 0. So I'm going to put those points in. And then my y-intercept, let me make this this y-axis go down a little further because the y-intercept is way down at y equals at the point 0, -12. Okay, so I'm going to find my point of symmetry now. I see my axis of symmetry has an x of 4, so the y-axis is 4 units to the left. So if I go 4 units to the right, I will find a symmetric point. So that would be the point 8, -12. So now I know another point I can put up here, 8, -12. And the final thing that I want to do is graph my parabola. So that's going to be, it's always a curve, and it's going to go up. High point is the vertex, it turns around and comes back down. There's no straight lines when I'm doing that. It's just kind of a curve that curves through the vertex. All right, and that would be my answer.